Hello everyone, my name is Ritik. Welcome to my workshop presentation for GGR463. Today, I'll be discussing my progress on my project so far. My project is related to finding suitable locations for level 3 fast chargers for electric vehicles across the GTA. So here's a brief introduction on what I'm trying to figure out with this project. There's been a rapid increase in the adoption of electric vehicles over the past decade. Approximately 379,000 EVs were registered between Jan and October of 2021, and this is a 94% increase compared to 2020. The total market share of electric vehicles grew from 1.75 to 2.9 during this time period. The market share is expected to grow exponentially over the next 2 decades. There are various reasons why people are switching to an electric vehicle as opposed to a fuel-based alternative. These include lower maintenance costs, more affordable running costs, and contribution to the reduction in climate change. In this project, I aim to identify suitable locations for level 3 fast charging stations for electric vehicles. Electric vehicles are expected to account for almost 100% of vehicle sales by the end of the next 2 decades. All EVs use the same standard plug for level 1 and level 2, but different brands of vehicles require different adapters for fast charging of their vehicles. As of 2022, the GTA has 864 public charging stations, which are of level 2 and level 3. Of these, the majority are level 2 chargers, approximately 93%. Although this number is sustainable for now, it needs to be continuously increased to keep up with the increase in the use of electric vehicles. This project will be useful in determining optimal locations for level 3 fast charging stations across the Greater Toronto Area, as it is a problem that needs to be addressed throughout the next 2 decades. The primary objective of this project, as I've mentioned before, is to determine suitable locations for new charging stations across the Greater Toronto Area. I aim to take current charging station locations into account while determining optimal locations for new charging stations. Level 3 electric chargers are universal chargers that can charge electric vehicles up to 80% capacity in approximately 30 minutes. And currently, there are only 57 level 3 charging stations across GTA. Time to charge a vehicle is an important factor in ensuring an efficient process. This project will focus on determining optimal locations for these level 3 fast chargers. So here's the data that I'm using for this project. I'm using the GTA census boundary shape for mapping purposes. I'm also looking at current electric vehicle charging stations. I'm looking at current fuel stations. So these are the gas stations and how they're spread across the GTA to kind of get an idea of how electric vehicle stations should be spread out over the next 2 decades, because by the end of 2030, almost 100% of vehicle sales are expected to be EVs. And then I also have data for the electrical utility load available. So this is the amount of electrical energy that's available for use in a certain area. So this is my project workflow. So far, I've done my background research on this topic. I've defined the questions that I want to answer, which is where I want to place these new level 3 fast chargers. I've completed data collection, so I believe I have all of the data that I need for this project. I've done some EDA and also some data cleaning, and I've kind of just started my GIS analysis, and I've started to answer the questions that I'm looking answers for. And I'm yet to interpret the results of my analysis and visualize these in the form of maps and make a conclusion. So here's some of the methods that I'll be using for analysis to help answer this question. So I'll be creating buffers of existing level 3 chargers within certain ranges. So EVs approximately on average, they're able to travel for 200 kilometers before the battery dies. So I'll be using a number according to this figure to create these buffers. I'm also doing just some basic exploratory data analysis to find patterns and trends in this data and see what areas of the GTA that I need to focus on, which areas are currently not developed enough in the terms of EV charging facilities. And I'm also going to do closest facility analysis to find suitable locations. So here's some of the results from my EDA. So here I'm just plotting, it's a simple bar graph. I'm just plotting how many level 3 fast chargers there are currently in the GTA. So as you can see, most of them are located in bigger cities such as Toronto or Mississauga, and the rest of the cities just have a handful of them. The most you can see after GTA or Mississauga is Burlington with about 5 charging stations. Actually, it's Markham with about 10, and then Burlington, and the rest of them have under 5 stations for the entire city. So here I created a map of the spatial distribution of the current locations of type 3 chargers in the GTA. So as you can see, it's pretty clustered in the downtown area, and it's relatively more spread out in Mississauga. And here you can see in Markham, it's kind of clustered as well. So as you can see, and imagine if there's a person that lives in this area, they don't have the same accessibility to these charging stations as compared to someone who lives in this area or even here in Markham. So yeah, that is the goal of this project, to determine new suitable locations. So here I did a buffer analysis, and I just created 5-kilometer buffers around these existing EV stations. So this is kind of to see if someone's battery is about to die and if they have about 5 or 10 kilometers left on them, how close they need to be to an existing EV station to be able to get there in time and charge their vehicle. So again, this highlights the problem that I'm trying to solve. As you can see, if there's someone in this area and their battery is about to die and they have like 5 or 10 kilometers left on their car, they won't be able to successfully make it to a charging station. So that is a problem that I'm trying to solve. So some of my next steps are, I want to find new GIS analysis techniques that I'd be able to apply in this project. And one thing that I haven't done so far is connect the different parameters that I'm looking at. So I really want to connect the electrical utility availability and current gas stations data in this analysis. Electrical utility availability is a big one because you need to have the electricity available to be able to power these EV stations, especially level 3. Those require much more amounts of electricity as it's fast charging. There's going to be more traffic in these areas, so it just needs to constantly charge vehicles. As I said, it charges a car to 80% capacity in just 30 minutes. And then after that, I also aim on using different QGIS spatial plugins for analysis, and I will be furthering my analysis by using R. So most of the EDA that you've seen so far, like the initial plots and stuff, were in R. I filtered my data in R, and then I kind of exported as a CSV and brought this data into QGIS to help me plot this on the maps that you've seen. And here's some of the roadblocks that I've encountered so far. So one of the biggest ones was that the depth of the project was not good enough to be able to have a full analysis on it. So this was in the initial phases where I didn't have as many parameters that I was looking at. But since then, I brainstormed other parameters that should be considered. And some of the most important ones that I came up with were electrical utility load availability, current gas stations, socioeconomic status, segregated by neighborhoods, and possibly population density. Population density does not completely make sense in the current context because there could be neighborhoods that are relatively poor and would not be able to afford electric cars in today's day and age. But this is subject to change in the future as EVs are becoming more and more affordable and accessible to the general public. I would keep population density as one of my least important parameters right now. Please let me know what you think of this. And I've collected all of this data, but I'm still trying to figure out how to tie all of this together and kind of what GIS analysis techniques I should be using to be able to successfully tie all of these together and carry out a successful project. Um, I've done some data cleaning since the proposal, and I've found some pretty valuable information, such as which cities currently have a lot of EV charging stations, type 3, and which don't. And yeah, the software that I used for my EDA was R. And I've also, as you've seen, that I've mapped the current electric charging stations on the map of GTA to get a perspective of the current spread of these stations. And as you've seen, I've also further mapped charging stations which are only type 3, which is the scope of this project. And now I would like to give credits to the template, the slide template. So I got it from SlidesGo. And yeah, thank you for watching my presentation. And I hope on getting some valuable feedback on how I can further my analysis and improve my project. Thank you.